You have a situation. What's that situation? First one's not in standard form. You got to rewrite it in standard form. Negative 4x to the 8th power plus 3x to the 4th power plus 6x to the 3rd power plus 2x. And at that point, now I can tell you that I have a degree of 8 and a leading coefficient of negative 4. You got to get it into standard form. That's the key. If it's a polynomial in one function, you got to get it into standard form. All right, the next one. What's the problem there? It's not a polynomial, much less a polynomial in one variable, right? All because this little piece right here is actually a negative exponent, right? So I'm going to write that. So this is not a polynomial in one variable. Because 4 over x, don't ask me where the c came from, is equal to 4x to the negative 1 power, and that negative 1 is a negative exponent, negative integer, and that makes that not a polynomial. Everybody good there? That was from the last lesson or lesson before last, right? What a polynomial was anyway. All right, so now we lead into the polynomial functions. Missed a U. Sorry. Continuous, yep. It's a continuous function that can be described as a polynomial equation in one variable.
How do you spell continuous?
C-O-N-T-I-N-U-O-U-S. I missed a U. Good thing I'm not the spelling teacher, right? All right, the power function. It's the simplest polynomial function. Taking the form f of x equals ax to the b power. Where a and b are non-zero real numbers. Can't be zero.
Is there anything but zero? No, well, I understand.
Sorry, my mouth was full, so I was trying to nod through that. You're fine. All right, so I want to take you back for just a minute to function notation. where we learned that now y was equal to that f of x notation. And we said that x, the x there is what replaces all the x's within the equation, right? We're going to use that function notation to start solving a few of these polynomial expressions or simplifying them. So we're going to find f of 3c minus 4 minus 5 times f of c. If f of x equals x squared plus 2x minus 3. All right, so in this situation, I'm going to start with two parts. I'm going to start looking at figuring out what f of 3c minus 4 is and just what f of c is. I'm going to start with those two pieces before I start figuring out the rest. So I'm going to use this function f of x, and I'm going to find what f of 3c minus 4 is, and that says that within this equation I'm going to plug 3c minus 4 in for every x within the equation, right? So that means right here I get 3c minus 4, and that's going to be squared, plus 2 times 3c minus 4 minus the 3. And I'm going to simplify this piece. So what are some things I'm going to need to do to simplify this piece?
Distribute.
I'm going to have to distribute here. I agree with that. What else? What am I going to do here?
You multiply the one variable by the same one.
Yeah, I have to multiply 2 of the 3c minus 4s. So what that looks like for me is 3c minus 4 times 3c minus 4. And I'm going to go ahead and distribute here. 2 times 3c is 6c. And 2 times negative 4 is negative 8. And then I have the minus 3 there that I need to bring down. How am I going to multiply these two binomials? What do I use? FOIL. So I've got 3c times 3c is 9c squared. And 3c times negative 4 is negative 12c. And negative 4 times 3c is negative 12c. And negative 4 times negative 4 is positive 16. And then I'm going to bring down the rest of this. Plus 6c minus 8 minus 3. Am I done? What do I need to do? Combine some like terms. So 9c squared, does anything combine with it? No, I'm going to bring that down. Then I have negative 12c, and positive 6c. So negative 24c plus 6c is negative 18c. And then lastly, I have 16 minus 8 is 8. Minus 3 more is 5. All right, so this piece right here is now equivalent to this piece right here. Does everybody agree? Okay. Now I'm going to do the same for f of c. I want to know what f of c is. And that means everywhere in the equation, I'm just going to plug in c instead of x. So right here, I've got c squared plus 2c minus 3. All right, so now I can plug these two things in. So So I'm going to take this f of 3c minus 4 minus 5 times f of c. And I want you to try to finish that before you come in tomorrow. Okay? We'll stop right there. Of putting it all together. So what that looks like for us is I've rewritten the problem, f of 3c minus 4 minus 5 times f of c, and I'm going to plug in what I found f of 3c minus 4 to be, which was the 9c squared minus 18c plus 5. Then I'm going to subtract 5, and now I'm going to put the f of c, which was c squared plus 2c minus 3. So now what do you see here that I have as a next step? Got to distribute the negative 5 to everything inside the parentheses. So I have 9c squared minus 18c plus 5, and now I'm distributing negative 5c squared minus 10c plus 15. And last step would be to do what? Combine like terms. So I have 9c squared minus 5c squared, which is 4c squared, negative 18c and negative 10c make negative 28c, and 5 and 15 make 20. All right, any questions there on that type of problem? None? Got it? Okay. Then I want you to try this one. All right, so practice 3. Find g of 5a minus 2. You can follow the same steps we did yesterday on the first one, plus 3 times g of 2a if g of x equals x squared minus 5x plus 8. So you're going to do it in 2 phases again. You got to find g of 5a minus 2 and g of 2a, and then plug them in and find the final simplified piece. I'll give you just a minute to do. All right, so looking at the problem here, it's the same steps as yesterday. You're taking 5a minus 2, and everywhere there's an x, you're plugging in 5a minus 2, right? So it should have been 5a minus 2 squared minus 5 times 5a minus 2 plus 8. That's what your first one should have been. And the next step was to multiply out the 5a minus 2 times 5a minus 2, right? There were 2 of them. And then also distribute the negative 5 across the 5a minus 2. So this is the first and second step there. So multiplying out the 5a minus 2 times 5a minus 2 and distributing the negative 5. So check your lines, make sure you got that part right. Okay. Next step was to combine like terms, and that was my final g of 5a minus 2 is equal to 25a squared minus 45a plus 22. So that line, this piece right here, can be replaced in the problem of the part that says g of 5a minus 2, right? Now there was another function we had to find, the g of 2a, right? So g of 2a said everywhere there was x, I'm going to put 2a. So that's what that one looks like. 2a squared, the whole thing 2a squared, not just 2a squared, but 2a all squared, right? And then minus 5 times 2a plus 8. So again, I'm multiplying, I'm getting this exponent piece, so 2a times 2a, which would have been 4a squared, and negative 5 times 2a, which would be negative 10a. And then, did it have any like terms to combine? No. So the next thing I did was write down that oh, no I didn't. No I didn't. I thought I did. It is to go back in and plug in these parts to the original problem, right? So I'm taking 25a minus 45a plus 22 and putting it there. And I'm taking 4a squared minus 10a plus 8 and putting it there. So that's what this line is. I plugged those two into the original problem. Does everybody see that? And the only other part I need to do now is two pieces. I'm going to distribute and combine like terms. So I distributed and combined like terms, and there's the caboose answer. Were we having questions or problems? Questions or problems anywhere?
I was confused about the second part, but I figured I understood.
This part here?
Yes, ma'am.
Okay. So just plugging it, what you found to be those functions back up in to the original problem. Anybody else? Questions? None? All right. Well, we'll move into the next part of today. It's a lot of writing, so I'm just going to pull it up on the screen, let you guys write away. All right, so we're looking at the graphs of polynomials. For the graphs of polynomials, we're looking at their degree and how the graphs look. So I'm going to describe a few things here, and then we'll have more detail on them on the next page. So we have a constant, which was the one that had like x to the 0 power. It was just the number by itself. So it's carrying a degree of 0, which gives me a horizontal line. The horizontal line neither goes up nor down. It just goes straight left to right. It doesn't even cross the x-axis. The linears, which are a degree of 1, actually go up and down. They extend forever in both directions. And with a degree of 1, they're also crossing the the x-axis one time. They're crossing the x-axis one time. It has one possible real 0. Quadratics, they have our x squareds, so they're degree of 2. And with the degree of 2, they both have an end behavior that both ends are going the same direction. They have the possibility of 2 real zeros. Cubic, with a degree of 3, extend indefinitely in both directions, like linear. Degree of 3 and degree of 1 both go in opposite directions, and the cubic has a possibility of 3 real zeros. That's the possibility of crossing the x-axis 3 times. Quartic, with a degree of 4, extends in the same direction. Note the similarities of quadratic and quartic. Both ends going the same direction. That's going to be important to us in a minute. Quartic with a degree of 4 also has the possibility of crossing the x-axis and having 4 real zeros. And then the last one, quintic, which is like which is degree 5, extends in both directions like the cubic and the linear. You'll start seeing the pattern happening there. 1, 3, and 5 go opposite directions. 2 and 4 go the same. Quintic also has the possibility of 5 real zeros. 5 possible places it can cross the x-axis.